Okay, so we're on the second day of notes for this section. So now that we've talked about indefinite integrals that don't have bounds, we're going to go back to 5.3, which is definite integrals. Definite integrals have defined endpoints. Definite are defined at the ends. All right, let me shut the door. Don't want to bother the teachers who don't teach right now. Okay, so let's look and see what this means. Oh my god, this is so slow. No. I try to be here like around 7-ish to 7:30 every day, just so I could beat the person who parks next to me, because they always park in my spot, like I want to be able to open my door without hitting my face when I'm trying to get out. I'm not telling you, this is personal business, okay? But that's the big reason why, and also traffic sucks getting out of my house. What?
That's so why don't you leave a note on their car? So
passive aggressive? No thanks. I'd rather just be pure aggressive. Thank you. All right. Slash their tires. Kidding. Just kidding. So what I do is I just get to school before them and make sure to park in my lines. Therefore, if they park over the line into my spot, they will have to shimmy to get out of their car.
So Brian, you should go publicize the length of your...
No, I'm good.
Go like that.
All right. So if we take the derivative of an antiderivative, you get back the function. So this means the integral is an antiderivative of f. Okay, cool. It's the opposite direction. Instead of taking a derivative, you're saying this is the derivative of what function? It's kind of like you're solving a puzzle. This is what we talked about last time. Hello? So if f is any antiderivative of lowercase f, then we just have to tack on a plus c. This is just mostly review of what we did last time, because remember we went over 6.2, and that talks about indefinite integrals, but chapter 6 is after chapter 5, so hopefully this is a nice little review. So if you remember our example, if my example was 2x, there's many functions that this could be the derivative of. So for instance, I could have, what if f of x was equal to x squared? The derivative would be 2x. What if f of x was equal to x squared plus 5? What's the derivative of x squared plus 5? 2x. What's the derivative of x squared plus, Spencer, give me a number, any number.
5.
I just have 5.
115.
115. Okay, so I already said 5. 115. Literally x squared plus any number, right? The derivative would always be 2x. Now, antiderivatives, aka integrals, are solving a puzzle, because you're trying to, instead of taking a function and then you will find the derivative, we start with the derivative, and it's like a little puzzle. You're like, okay, what function is the derivative what I have? So you're trying to like work backwards. Instead of having a function, taking the derivative using rules, we start with the derivative and then we go backwards and say, okay, what function could this be the derivative of? Now this is why we add the plus c, because notice all of these functions, the derivative is 2x. So if I have 2x and I'm trying to take the antiderivative, there's infinite number of options. Okay, I could have x squared. That could be my function, x squared plus 5, x squared plus 115. That's why we add the plus c, because it's adding a constant. And so in order to actually solve for what the constant would be, you had to have an initial value. Like you have to say, oh yeah, when x is 0, y is 0. Okay, we plug that in and we can solve what the c would be. All right. What else do I want to say? Okay. So setting x equals a in this equation. So notice here we're going from a to x, but what if we set x equal to a? Oh, it's the exact same thing. Wait, we just learned this. If you're taking the integral of, this is the 0 property. Am I blind? I'm blind. Blind. Nope, here we go. Okay. Right here. If I'm taking the integral from a to a, literally, that is a width of 0. You're trying to find the area starting at a, ending at a. Okay, that's like no width at all. That's why it's an integral of 0, because it gives you no area. Because if you have a square, right, a rectangle, whatever, and you're trying to do, like length times width? What if your width is 0? You have no width. What would the area be? 0. Right? If width is 0 and you try to take the area of length times width, you're literally taking length times 0. That's what this is doing right here, because integrals are what we learned in the first part of the chapter. finding area under a line, under a function. We're finding the area. So the integral's finding our area. If I'm going from 1 to 1, that's a width of 0. I can't actually make a rectangle because there's no width. It's infinitely thin. Okay, I'm just trying to like help you remember what we already went over. Keep going down. Yes, here. Okay, so if I instead set x equal to a, I am having the same bounds on top and bottom. Therefore, we know this should equal 0. So this means f of a plus c is equal to 0, and this is exactly what I was just talking about. You plug in your initial values, and you can find what your c should be. Okay. So putting this all together, if I'm going from a to x, taking the antiderivative, aka we're not just doing indefinite, we actually have defined endpoints. The way you do it is you take f of x minus f of a. So notice this is not the lowercase f's. You're calculating the antiderivative at b and a. So you have the function f of t. First, you have to find what the antiderivative would be, which is capital F of x. So I give you the derivative, and you solve the puzzle and say, okay, what function is this the derivative of? Okay, and then you have the antiderivative. And then once you have that, you're going to evaluate your two endpoints there. So you're evaluating the antiderivative at b and a. Okay, I think that's a lot of like, an example would probably make more sense than me like talking about it because there's a lot of vocab that you can get lost in. Okay, evaluate the integral using the antiderivative of the quantity using the formula from a to x of f of t dt is going to be our antiderivative at x minus antiderivative at a. So you're taking, so first you have to figure out, here's the derivative, what is the antiderivative function? Then you evaluate your two endpoints at that point. Okay, so let's start with the first one, sine. Now, I'm given sine. Sine is the derivative of what function? When you take the derivative of what function do you get sine?
Negative cosine.
Negative cosine. Because, okay, ready? Remember, if you take the derivative of cosine, what do you get? Negative sine x. Okay, so if you take the derivative of negative cosine x, what do you get? Sine x. So remember, we're trying to find the antiderivative. AKA, what thing did we take the derivative of to get what we have inside? So we take the derivative of what function to get sine? Negative cosine. Okay. So this is literally going to be negative cosine of x, and we're evaluating at 0 and at pi because that's our bottom. We're going from 0 to pi. This is the way you write it. It's because you have the square brackets. First thing you always do, solve for the antiderivative function. And then you write your endpoints, like you have to use square brackets, use your endpoints at the top and bottom. You always do the top, right? Plug in the top one and then minus plugged in on the bottom one. So what this looks like is negative cosine of pi minus negative cosine of 0. What is cosine of pi?
Let me think.
So remember, cosine is x.
1.
Negative 1.
So cosine of pi is negative 1. Negative of negative 1 is 1. Minus. And then cosine of 0 is 1. So if you multiply by negative 1, it's negative 1. So this is just going to be 2. That's it. That's how you evaluate it.
Oh.
Yeah, so it's, I'm trying to think of like a better way to explain it. The book has all this like high level. I'm trying to break it down for you so you like get the method. Yes.
Why don't we have to write plus?
Because we are evaluating it from 0 to pi versus if it was just the indefinite integral, you would add plus c.
So only indefinite integral uses c.
Because, okay, we're not trying to, that was not a good explanation. I don't like the way I said that. Let me think. So when you evaluate, you just find the antiderivative and then you plug in to find the actual area. The antiderivative is trying to find the exact like area. That's not a good explanation either. Let me think about a better way to explain this. I don't know. Sometimes let me think about this and I'll come back to it, I promise. Okay? I'll think about this. All right, let's try the next one. Actually, let's show you the plot. Okay, this is pi, this is 2 pi. Do you remember what cosine looks like? 0, max, 0, min, 0. So we're finding the area from 0 to pi.
Wait, isn't cosine 1?
Oh, hold on. Sorry, I was drawing sine. I'm sorry, I was drawing sine.
Is that what you draw? Like if when it gives you that little sign of x dx, are you graphing sine x?
Well, this is the function we're given.
So that's the function.
Integral is finding the area underneath. More or less, that's what it means.
Oh, okay.
So if you take the antiderivative and then evaluate it, you actually find the area. Okay, let's try the next one. Okay, I have an explanation that I'm happy with. Ready, Ty? I think this is your question. So if I added the plus c, right? So I have negative cosine of pi plus c minus, let's see, negative cosine of 0 plus c. Guess what happens to the c? You have a c minus c, it goes away. There you go. That's the clearest explanation I can give. Okay, cool.
Won't that always happen?
Yes, that's why we don't include the plus c. That's why I didn't include it, and why I won't for definite integrals.
So only indefinite integrals use c. That's a good thing to remember.
Indefinite?
Yeah, only indefinite.
Indefinite, right, where you don't have defined endpoints.
Okay.
Okay, yeah. Because it will, like, when we're evaluating, it cancels itself out. Ah, okay, cool. That's a better explanation. All right, so what does this graph look like? What's the graph of 3x squared look like?
It's a parabola.
It's a parabola, okay. Looks something like that. And if we're taking the area from -1 to 2, literally we're trying to find this area. Right, integrals, we're finding the area under the graph. In order to find this area, we are going to take the antiderivative. Okay, so what this means, what function, when you take the derivative, will be 3x squared. So I'm trying to go backwards. Do you remember? So you add 1 to the exponent, so 1 plus 2 is 3. So I'm going to add 1 to the exponent. And then my new exponent is 3, so I'll divide by 3. So this is just going to be equal to x cubed, evaluating from -1 to 2. So if I plug in, you do the top minus the bottom, your b minus your a. So I'm going to plug in 2 cubed minus my -1 cubed. So that's 8 minus a -1, so it's plus 1, so you get 9. Yeah, how do you feel about this? Yeah?
Will you always subtract the 2?
So it's always b minus a right here. F of x, f of the top minus f of the bottom. So it's always your b minus your a. Your top end minus the bottom evaluated.
Will there ever be addition or no?
Well, I mean, technically this was, right? Because two negatives make a positive. Okay. We're okay. Yeah, we're doing good. It's just the hardest part is it's the puzzle. You're like, okay, I have to go backwards. I'm not taking the derivative. This is the derivative. What did I start with? It's just a puzzle. We're good. Let's try the next one. Ooh, okay. So, remember, if we're taking the derivative, you would subtract 1 from the exponent. We're taking the antiderivative. So you add 1 to the exponent. And then we're going to be dividing by our new exponent. Okay, so -2 plus 1 is -1. Divide by -1. So I have negative x to the -1 over -1. And we're evaluating from 1 to 2. Yeah, 1 to 2? Yeah, 1 to 2. So this is just going to be 1 over x. evaluated from 1 to 2. So there's two ways of writing it. I want to show you both ways because if you take calc in college, who knows what your professor's going to do? I don't. Some of these people are whack. Literally, it's part of their funding. They have to be teachers. I don't know. Maybe it's just my math teachers in college are crazy. Okay. So this is square brackets, evaluating from 1 to 2, or you could have like the long line, evaluate from 1 to 2. It means the same thing, yeah? I'm probably going to use this way just because I do it the same way every time. Question? Yes?
How do you get from that to that?
Okay, so if you have a negative on top, negative on bottom, then negative cancels out, yeah? Negative cancels out. And then when you have a negative exponent, you make it positive by moving on the other side, yeah? Cool. Okay, so we got to evaluate from 1 to 2. So I have 1 over 2 minus 1 over 1. That's just 1/2 minus 1, so it's just going to be negative 1/2. Ooh, what does this mean about our graph? Like, this area is going to be, yeah, there's more below than on top. There's more below the x-axis than on top. Okay, let's keep going. Hey, okay, so my plan is it'd be great if we like finish the notes, have any questions on the worksheet from before, I hand out the new worksheet. Be great. Okay, we're always working backwards. We're given secant squared x. So what function, when you take the derivative, is secant squared x? Tangent. Okay, so this is going to be tangent of x, and we're evaluating from 0 to pi over 4. So take tan of pi over 4 minus tan of 0. So tangent of 45 degrees, 1. We don't remember this. Okay, cool. Yeah. Because pi over 1. Because it's sine over cosine, pi over 2 over 2 divided by pi over 2 over 2. So that's just 1. And then tangent of 0 is 0. So it's just going to be 1.
So 1 minus 0.
It's just 1, yeah. Yeah, 1 page down.
Can our calculators do that for us? Like if you plug in tangent of pi over 4, if it's in radians, will it tell you?
Yeah, I will tell you. I'll tell you. Is there another one I wanted to do? Okay, okay. I'm gonna do one more example. It's not on your page, Coolio, before I move on. Hopefully you have a little bit of room. I'll just label this E. So what I'm going to do is I'm going to say my function's y equals x. I'd like to take the integral from 1 to 4 of x dx. So let's see what this would look like. This is our function. Looks something like this. And if I'm wanting the area from 1 to 4, so it's 1, 2, 3, 4. Oops. It'd be something like this. So you could easily find the area using geometry. What shape is this that I drew? Yes, I did. That's why it's on. Yeah. What shape is this? Trapezoid. It's trapezoid. Because we have one base, the second base, here's the height, and then you have the sloping side. So it's a trapezoid. So if I wanted to find the area of my trapezoid, it's 1/2. This is my height of 3. Plus base 1 is going to be 1. Base 2 is 4. So this is just going to be 5 times 3 is 15. 15 over 2. This is what our answer should be. This is how we did it in the first, what is it? Second? Is there a second or third lesson? I don't remember. We did this before the quiz. This is how we found it. We just found the area of a trapezoid. Now I'm going to prove to you it's the exact same thing. It's a nice little practice. Okay, so to take the, I have a function that's x. This is the derivative of what function? Okay, so you add 1 to your exponent and you divide by your new exponent. So this is just going to be x squared over 2, evaluated from 1 to 4. Because you're given x, technically this is x to the first, add 1 to the exponent, now you have x to the second, divide by your new exponent, so you divide by 2. Okay, so this is just going to be, let's see, 4 squared, 16 over 2. I should actually write it for you. 4 squared over 2 minus 1 squared over 2. So that's 16 over 2 minus 1 over 2, so that's 15 over 2. We get the exact same answer. It's just, I don't know, it's another extra little practice, you know, semi-doable practice. Shows you what we did. Finding the area gives you the exact same thing as the integral that we do. Okay. The average value, the mean value theorem. Let's go on. Okay, so if f is integrable on a to b, means you can take an integral. You okay?
Yeah.
She's like,
Going off for hydrated.
okay. Okay.
Nothing to be ashamed of.
If you can take an integral between your two endpoints, a and b, its average value is just going to be 1 over b minus a times the integral from a to b f of x dx. Wow, that's a lot to say. So literally you're taking the average over, okay, so you take the integral. This is exactly what we did on the first page, aka the page we just did. Right, you find the antiderivative, plug in b, minus the a, plugged into the antiderivative, but then you have to multiply by this pesky 1 over b minus a. Whatever, it's just one more step, it's fine. This is just the mean value. Okay, so find the average value of f of x equals 4 minus x squared from 0 to 3. At what points in the interval does the function assume its average value? So there's two things we have to do. Find the average value, and then see when do we actually have that as our y value. Okay, so to find the average value, it's 1 over b minus a. So, ready, this is our a, this is our b, because where you start is your a, where you end is your b. So b minus a, so that's 3 minus 0. And then I'm taking the integral from 0 to 3 of 4 minus x squared. And then, don't forget to put parentheses, dx. Whenever you have an integral, you have to have a dx with it. Can you see? Is that okay? Okay, it's not too different than what we just did. So I have 4 minus x squared. I have to say, okay, I treat it just like the polynomial. Add 1 to the exponents, divide by our new exponent. This is 1/3 times, okay, when I have 4, technically it's 4 times x to the 0. So if I add 1 to the exponent, it's going to be 4x to the first over 1. Okay, leave it alone. And then if I add 1 to the exponent of x squared, I have minus x cubed, and then I have to divide by our new exponent 3. And I'm going from 0 to 3. Let me pause here. I don't want to zoom through. Are we okay with this? What questions do we have? Yes.
I know this is from a while ago, but when you're finding the antiderivative of negative x squared, like I get it's x over 3 and with the 3, but is the whole thing cubed or just the x cubed?
No, just the x. Because what you do, technically this is right here, x is 0, you add 1 to the exponent, divide by your new exponent, add 1 to your exponent, divide by your new exponent. Yeah. Okay, let's go ahead and let's evaluate. Whew, so this is just 1/3. Okay, plug in 3. 4 times 3 minus 3 cubed over 3. What happens when I plug in 0 for x? Right, it's just going to be 0. So I have 1/3 of, let's see, 12 minus 27 over 3 is 9. So 3, oh wow, it's just going to be 1. So this is the average value. Coolio, this is the average value. Now we have to go through and see at what points, at what x values on our interval is the y value, is the function going to equal 1. right? At what points in the interval does the function assume its average value, aka when is our average value actually going to equal the original function? So what should I do? Exactly, 4 minus x squared. I'm going to write it the other way. I'm going to say 1 equals 4 minus x squared because I have the average value on the left, original function on the right. Just go through and solve. So it's going to be x is equal to plus or minus square root of 3. Cool, that's the answer, right? Plus or minus? They both are on our interval? No, we're on our interval 0 to 3, so we only want to include positive root 3 because this is the only one that's actually in our interval. Okay. Sorry, can you not read something?
Oh, you still have to plug it into the original.
Yes, because we're looking for at what point does the function assume its average value? At what point do we have a y value that's going to be 1? Okay. Cool. So this is just the same thing. I literally went over this.
Yeah.
Mean value theorem. Yeah.
How come only positive 3 works again?
Because negative root 3 is not in between 0 and 3. This is the only one that's in our interval.
Oh.
Am I good to scroll down? Okay. So mean value theorem for definite integrals. If f is continuous on between your two endpoints, and then at some point c between there, it will actually equal the mean value. That's what we just saw. If you take the average value of a function, okay. If you take the average value, there's going to be at least one point where it's actually going to be that y value. That's all we just showed you. There's at least one point where the function assumes its average value. That's what this is trying to say. So the homework associated with this second part of the homework is the integration worksheet. So keep in mind, I cut this out, right? Remember we talked about this last time? I'm not having you do this book assignment. I gave you 2 worksheets instead. And this is what is reflected on MyJag. This is what I told you last time. This is what I'm telling you right now. Please, I don't know, write this down. I'm going to give you the worksheet. We have a little less than 20 minutes. We can go over questions from the last worksheet, or you can work on this new one. Cool. Yeah. Look what happens when we get through stuff. We really try to answer the questions. Awesome. Yes. So I sent this to you. Also, there's a copy on MyJag. I don't know why some of the numbers just disappeared. Sorry, you're gonna have to look. Good luck, Sean. Will you pass these down?
Can I have one? Yes, I can have one.
Just a reminder, next week is the junior trip. So if you're a senior, you're expected to be here on time. I'm gonna have some worksheets for you guys to do together. You can do it in partners, whatever. But the plan is the first day, reviewing chapter 3 key concepts. How do you take a derivative? Then there's 2 different days reviewing chapter 4, and there's midday where you're more practicing integrals. honestly, this is supposed to help you with your final, forcing you to stay here in class and work together. Like, this is good for you. Also, it will give you good points in the grade book. Yeah, good. Okay, question or question?
Did we, in the notes, there weren't any questions where we like went over on the fractions, 2 times x to negative 2?
Can we do number 9 on
Oh, you just move
the
it.
first one of 500?
Okay, sorry, Ellie, you had a question, and then I'll get to Noah. Do you have a question? No? Okay, cool.
Also, are there
So,
homework that are gonna be like not enough information?
not what?
Not enough information for like,
Um,
because like 8 and 9, I could.
I know.
Because you don't have
okay, which,
on the first
number 8, there's not enough info. Number 9, there's not enough info.
Okay, that's fine.
Yeah. Cool. Okay, let's go to the first one. Correct.
But can't you do that one minus that one?
Which one?
That one minus that one?
F of x. Number 8 is h of x. It's a different function. Number 8.
So these two you can't do?
Right.
That makes sense. Okay.
You like everything
Okay, here we go. Which numbers did you guys want to go over? 1, 2, 3, 4 is the first one. People said they wanted to do some together.
We do 15 on the back.
Okay. Okay, so you're looking at secant x tan x.
Is this the first one or?
Yes, this is the first one. So the derivative of what function is secant x tan x? Secant x. I don't know why it's doing this right now. So if you take, oh my gosh, no. I swear like dust gets in here. Okay, if you take the derivative of secant of x, you get secant x tan x. Alright, so secant x tan x is the derivative of secant x, which means the antiderivative of secant x tan x is secant of x. This is just secant of x plus c. That's it. What other? 18. Cool. Yes, that's the question she asked me about. So I'm first going to rewrite this as integral of 2 times x to the negative 2 dx. So you add 1 to your exponent, right? So 2 times x to the negative 1, and I'm going to be dividing by, let me change my color. So add 1 to your exponent, so this is to the negative 1 power. Then I'll divide by negative 1. Divide by your new exponent. So this is going to be, let's see, negative 2 over x plus c.
Cool.
Yeah. Did you get it?
No.
No.
But look at it, I got it out.
I just don't, okay, the point is not for you guys just to like copy. I want you to like try it first. Yeah.
We did 19 then too.
Yeah,
Kind of
just
just
really expose myself. Sorry.
So number 19. So what you could do is first I'm multiplying by a negative 1. So I could literally pull out the negative 1 since it's a constant. And then I could just take the antiderivative of 1 over x dx. So this might, because I'm trying to put it in like, simplify, I don't know, move it around a little bit so you can recognize it a little better. Because remember my thought process, I'm trying to teach it to you like it's a puzzle. So 1 over x is the derivative of what function? What function you take as derivative is 1 over x?
Absolute value.
Natural log. And so here it's -1 times natural log, except the weird thing is when you take the antiderivative, you have to say of absolute value of x, ln of absolute value of x plus c. So this is just negative ln, just a moment, absolute value of x plus c.
I bet you already answered it.
That's fine. What?
What is antiderivative?
Okay, so if you take a derivative, so you have a function, you take the derivative, right? It tells you how the original function is changing. If you start with a derivative, you want to go the opposite way. You want to take an antiderivative, like go back to the original function.
So when
you're taking an
derivative, then like you're just saying
what?
like are you just
Antiderivative and derivative don't mean the same thing.
saying,
It's
but are you
anti. It's like the
antiderivative? I know, but how do you know like
Integral, the integral symbol.
yeah, no, but I'm saying like how do you find it? It's the same as finding a derivative.
No. So this is the derivative. 1 over x is the derivative of what function? So when I'm taking integral, I'm trying to go the opposite direction. I'm not trying to take the derivative of this function. This is the derivative, and I want to know what the original function was. So instead of taking a derivative, you're going the opposite way. So you're taking an antiderivative, like taking away, derivativizing, whatever.
So how do you can we do like an easier one? I have a question. Wait, well, I have a question on this
Wow.
one.
Which one is what?
This one. Why do you put the negative in front? Why can't you keep it?
Because I was trying to have you recognize 1 over x, because the derivative of ln of x is 1 over x. You didn't have to pull up the -1, but I was trying to make it easier for you guys to recognize something you've done before.
We didn't have like one with a negative, like added -6, or like a.
Well, we did one today, kind of like it. Yeah. The average value when we took the integral. Let's do an easier one. We can do 20. We can do 20. Actually, let's do 11 and then let's do 20. So we'll do 11 and then we'll do 20. So for instance, we have 3x dx. So the idea is, I'm trying to take the integral. What I'm trying to say is, if 3x is the derivative, what was my original function? That's what it means to take an antiderivative. You're saying if I'm given the derivative, I have to work backwards and give my original function. Because in chapter 3, remember when we learned how to take derivatives? I gave you a function and then you told me how it was changing. Now I'm trying to go the opposite way. I'm given the derivative, now I want the original function back. So the rule for this, so remember, when you take a derivative, you would subtract 1 on your exponent and multiply. When you take an antiderivative, it's opposite. You add 1 to your exponent and then divide by your new exponent. Okay, so you will add 1 to your exponent. So this is just x to the first plus 1, so that's 2, and I'll divide by 2. So this is just going to be, let's see, did I miss a negative sign? Is there a negative missing?
No.
Oh, okay, cool, I'm good. This is just 3x squared over 2. And then you have to tack on a plus c, because there's many, many functions whose derivative would be 3x. I could have 3x squared over 2 plus 1, 3x squared over 2 minus 50. All of these, when you take the derivative, would be 3x. That's why we have to add on the plus c, because we're not being specific. Because it could be, there's a whole family of functions that have the same derivative. Okay, so it's just the box is the answer. We go through number 20.
I have a question.
Yes. Nope. What's up?
Do we need to take the derivative of number 11? Because I forgot how. Because I want to see
11?
how it
We
goes
just did.
back.
Oh. Number. Got it. So, let's do this first one, yeah? 3x squared over 2 plus 1. Okay, let's take the derivative, d dx. This is also why one of your worksheets next week is taking derivatives. Really trying to prep you. Okay, so you subtract 1 on your exponent, and you divide and you multiply by your old exponent. So 2 times 3x over 2, the 2 goes away. So you're left with 3x. And then what's the derivative of a constant? 0. So it's just 3x.
I got it.
Cool. Okay. Let's go down to number 20, and then I can open it up for 3x squared over 2 plus c. It's the one in blue. She just want to know how to take a derivative again. Okay, number 20. Okay, step by step. So, do you want me to show you the short way or the longer way? Short way, okay. So, technically, what you could do is you could split this up into integral 4 cosine x minus integral of 6, right? That way you break it up into 2. And then, wait, if this is a constant, I can pull it out front. So, it's literally 4 times the integral of cosine x minus integral of 6. Okay, what? So, that's how I'm going to deal with the numbers. That was the long way, but now I'm going to do it the short way. So,
Pull 4 up front.
cosine is the derivative of what function? What function you take as derivative is going to be cosine?
Sine x.
Sine x. So this is going to be 4 sine x minus, okay, ready? This is technically 6x to the 0 because it's a constant. Because x to the 0 is 1. So if I go and add 1 to my exponent, I just get x to the first, and then I divide by 1 itself.
You subtract or you add 1?
Add 1.
Plus C, right?
Yeah, plus c. That's the short way.
Never forget the plus.
I'm going to do it the long way to really show you, like, wait, how did you get all of this? Oh my god. So you have 4 times sine x minus 6 times x to the first, and then you have to add a plus c. Type this on.
I have a question. If you're doing that, what do you do with, you know how you're supposed to put it under?
What?
If I'm doing that, aren't you, you know how you're supposed to put the 2 under the x?
Well, I would rewrite it as x to negative 1
And then
minus
just flip it
4x to
and
negative
multiply?
2. So, because you have 1 over x minus 4x squared plus 1, so you're going to have an ln.
Oh.
Because if you add 1, because you have x to negative 1. Oh, I don't do that one. Alright, why don't we do one from the other sheet? Yeah? Let's do one from the other sheet. I want you guys to try number 2. Try number 2 from the new sheet I just passed out. What? Try number 2. We're doing your homework together.
But that one's a hard one.
Yes, that's why I'm having you try it so we can go over it together. We can do it together. Try it first. Try it first. Okay. Integration worksheet. Okay, wonderful. Try number 2. Hannah, are you done number 2? No? Okay, please try it. We're on the new worksheet. So this first part is like review of what we already did, right? These indefinite integrals, and then just kind of like meshes it together.
How come the ones don't show up?
I don't know. I don't know why it's like being a pain in the butt.
So it's just the same as.
So this first 8 problems are like review of what we did yesterday, and then yeah.
I was thinking it says interrogation.
I am interrogating you. I'm asking lots of questions.
Are we doing that one? That
Number
one's
2,
I thought
yes.
we were doing number 1. She just said 2.
I said 2 about 20 times. That's why I asked you, Hannah, did you do number 2? I can rewind the screencast and ask you.
What do you think? What do you expect?
Math? I'm expecting you to do integration. Let's go.
You want to count that?
What?
Does it have caffeine in it?
Yeah.
Wait, so we don't have any. I know you would probably answer that. We don't have any homeworks from the.
For 5.3, it's just the 2 worksheets.
Drugs, Elliot?
So the lesson plan, what?
5.2. Oh, we already tried.
Yeah. So the only new things from since the quiz is this 5.3, and I've given you 2 worksheets. Cool.
Is it ln of x? Remember the 4x?
When's the
to
test
negative
number?
first?
Well, I did give you a lesson plan.
Yeah, I know, but I don't March 5th. Oh my god, we're so good, guys.
March 5th.
Yours?
It is
Yours?
March 5th.
Is it your birthday?
It's not mine.
So
It's your birthday.
My birthday's tomorrow.
juniors are gone next week. There's 4 days, 4 worksheets for you guys to work together and review. We come back together, we do 5.4, we do 1 day review, and then you have the test the 5th, and then we start chapter 6 on the Monday, the 9th. Cool. Good talk. Good talk. It's your last chapter. I'm gonna tell you right now, I'm not gonna be here on the 9th, so bring headphones. I'm gonna make a screencast. There you go. It's Monday the 9th.
Why?
What? I'm taking the day off.
What? Because you have to deal with a bunch of kids.
It's the day after the marathon.
Young adults. I thought you already did the marathon.
It's March 8th.
No, she's been
Where's this
practicing.
weekend?
She's been
20 miles. Training.
I get out of breath by doing a hike. Training versus actually.
Yes.
That's crazy.
Don't your legs fall off?
She's supporting.
Yeah.
Okay, let's go. Let's do this.
Mr. Brian, I'm coming.
Yeah.
I'm back.
Yeah.
I'm coming. I'm running it with you.
We went on a hike too, Miss O'Brien.
But who else is
I went
doing
on
it? Mr. Brian,
premise
who's doing
for
it
like
with
an
you?
hour.
We went the wrong way and it was completely
I'm in a run club.
Oh,
LA Roadrunners?
No, we went like
No.
I had like 7,000 steps this weekend.
I'm
Miss
pretty much,
O'Brien.
I'm like the youngest person in my group.
Mr. Brian, I'm coming with.
No, you're not.
I'm coming to support.
No, you're not. I'm in the, because I'm part of the LA Roadrunners, they, like,
Roadrunners?
we are
Is that
the
what you
official training group of the LA Marathon, and so we're in the B corral, which is the elite. We're not elite. This girl's like,
What?
she's like, okay, follow me.
What?
We're gonna stick to the fence, and
How long
I'm not
does it
trying to run
take you
away.
to run a mile?
I don't know, too long. I'm slow. It's gonna be a long day.
But you're in the elite.
No, because I'm part of the official training group. No, I should be in
Roadrunner
like,
group?
I should be in corral like
the
way
road
back.
runners.
The
No,
route
but
runners.
can I come?
Do
Do
you
you
do
do
like-
like?
Yeah,
you
we
like
we have to water. You know the episode of The Office?
What if you automatic?
This was a mistake. I shouldn't have told you.
Miss O'Brien, you got this. Yeah, come on. And you're running.
What if you see us and it's the whole class and we're like, yo, Miss O'Brien! And they're like, why are
No, there's no way. You will not find
Make a
me.
sign that says road running.
You will not find me.
I'll say I'll give
We
you
throw
water.
water on her.
her.
You will not find me.
Yes, I will.
Oh yeah. We'll find her. Yeah, wait. Why would we not be able to find you?
I'm not telling you my like number.
So I'll just run.
I'll wait all day.
everyone, and then I'll find you. No, we'll
I'll look up
people
road
giving
runner
out
number.
waters.
They do need volunteers though. They do need
I'm
volunteers.
gonna volunteer. I'm coming.
You can get service learning hours probably.
Good. I need them. I have zero.
No,
class.
it's
You have a
not
class
a
field trip,
non-profit.
Mr. Brian?
Huh?
It's not a non-profit. Is it?
I thought it is.
The LA Marathon?
Yeah.
It doesn't matter.
It
It
doesn't
doesn't
matter.
donate.
I
You can get hours from the A's
I
law.
don't know.
No, but it's not.
Oh. I don't know. Okay, well, so
You take class field trip to the marathon?
no,
One shot.
nope. I will not be here that Monday.
On a Sunday?
Goodbye.
Is there like a live?
Oh, yeah.
A live feed?
Like,
Yeah, I send my family my number, and that way they automatically get notifications whenever I pass every like 10K or something.
Can I have your
What?
number?
Like every like 6 miles. So
that's really cool.
I'm in a slow group. I'm in a very slow group, and I'm in the slowest group of the
Hey,
roadrunners.
leisure.
But it is what it is.
You're
No,
still
all the
running a
guys are
marathon.
doing it. Oh
Like,
my
'cause
God,
they-
you're still elite.
Yeah,
You know
right,
that
I
too.
will.
Well, I just like tell myself a year and a half ago I was in a walking boot because I tore my Achilles. So like I just have to like you have to start somewhere.
Yeah.
Yeah, all summer I was in a walking boot. Yeah. So I'm speed walking the whole marathon.
You know what? It's
How long is that gonna take?
How long is the marathon?
Like 6 hours, 6.5 hours.
Because the dude's name had something like
But it's 15-minute miles. So it's 15-minute miles for 6 hours.
He's coming without marathons, running back.
But like
I hate cardio. Hey,
I'm not trying to hurt myself.
I'm going to see you there.
Okay. See you guys.